Okay, so the recording has started and we are at the 8th of April 2024, and this is a class on VFD models and how to apply them. And soon I will share my screen so that you don't have to look at my face with these lines on it. I can't seem to adjust the shades in this room that I'm in. So today we're going to go over different VFD models and what applications you use them for. There are, from any of the major manufacturers, pretty much the same class of drives. So I'm going to use Yaskawa as an example. I'll refer you to some of the other drive manufacturers so that you can get their equivalent model numbers. But basically, we all make the same classes of drives, with the exception of Yaskawa and the matrix drive, where we are unique. And in understanding these product lines, you'll be able to apply VFDs better. You'll be able to understand how to create, let me rephrase that. When you come across a competitive drive, you'll understand which tool you'll need to be competitive with that drive so that you can win the business or replace the older model, whatever it is that you're trying to do. So this is a good class for general knowledge of the VFD landscape. We'll focus on 600 volt and below, which is called low voltage variable frequency drives. And let me share the screen. I will use Yaskawa's website for the various model designations after I give you a short review on a PowerPoint. But this is Yaskawa's website, and I want to point out a couple of things. First of all, every one of you should please consider signing up on this website. Yaskawa will not barrage you with stuff. It's just not their habit. But what it allows you to do is get past the public firewall. Our public website is pretty decent, but the partner login, as we call it, what you do is you sign up and you go through a 24-hour qualification period where they send your name out to the local sales force, in this case us, and we say friend or enemy, and then you get access. So you want to do this anticipating a 24-hour delay till you get access. Now, once you're in, and you get a whole plethora of additional, whole layer of additional information. Now, the other thing I want to point out is under support and training, Yaskawa has a lot of good e-learning modules. I've used some of them in this training session, and that's the e-learning curriculum. They have some self-guided video training there. The other thing that I would point you to is the Solution Center, which I think is one of the best executed portions of Yaskawa's website. And the Solution Center is basically a search engine that allows you to ask questions, and we have been populating this database with recorded, annotated sessions from our tech support. So if you call into Yaskawa, 1-800-YASKAWA, you ask for drive tech support. There are a couple of other selections to get you to the correct model and application, and then you'll speak to a human being, and that is what we call level 1 tech support. Level 2 is when the junior engineer who's manning that desk refers you to his supervisor, a senior engineer. Level 3 is when it goes into full board applications engineering, because you've asked us something that's so difficult. And typically level 3 involves us getting involved from a local level, people like myself, Eric Hodges, Danny Peters, and attempting to deal with the issue that you've presented. Often level 3 will involve a field visit, but level 1 handles 85–90% of it. These young people that are on this desk are not just catalog regurgitators, which fortunately I find with so many other tech support lines. They are very well versed and trained in applications. You have to be a degreed engineer to make the level 1 tech support desk. And you have a full set of demos available to you. So if you present a programming problem, they can actually simulate it either on the computer-based simulation. We have drive simulators, programs you can download, by the way, that will simulate a GA 500 on your laptop, or they have the physical demos hooked up to motors on the training or the tech support desk behind their seats. So a very capable resource. Now, if I just type in something, I don't even know what I'm going to get here. I'm just making this up as I go. But there's NEMA 4X. So you get all kinds of data from our tech. I mean, there's a lot on just a random subject. Larry Fuson, a good friend of mine, he and I have worked for Yaskawa for years, used to tell me that our search engine sucked so bad as because if you put drives in it, you got nothing. And that was true at one point. It's not true anymore. We've really gotten our act together. So the Solution Center, not to beat the drum too hard, is a great resource for you. And it's the first place I would go if you have a technical issue or a product issue or an applications issue. Do one more. Just as an example, let's take something a little bit off the reservation here. Submersible pumps. Do we have anything on submersible pumps? It looks like we have a lot. Maybe because I misspelled it. And there you go. You get several discussions on using our drives with submersible pumps. Okay, be careful with your spelling. Obviously, we don't try to guess what you're saying. Yaskawa kind of literal and everything. So a small typo resulted in getting nothing. Now, let's just, first of all, bring this up. Oh, I think I'm going to pass that and do that. Okay, so the Yaskawa industrial VFD models, and I will also go over the HVAC models, but the Yaskawa industrial VFD models, you've caught us at a point where we're transitioning from 1000 series to the next series of drive numbers. And the next series of drive numbers is not going to be as consistent as the previous level. But we're changing the front two letters to be more applications oriented. In the 1000 series, we had the J1000, which was our little shaft turner dumb drive. And we sold a lot of them, but it is not advantageous enough to manufacture from a cost standpoint that we are going to continue to manufacture it. The J1000 is basically discontinued. And its bigger brother was the V1000, which is called a microdrive. And in the variable frequency drive industry, microdrive is an industry-wide term that refers to drives that we manufacture in enough volume to highly automate the line. And therefore, it used to be 25 horsepower and below. It's now 40 horsepower and below for Yaskawa, plus or minus a horsepower rating for all the other manufacturers. But those drives are manufactured in highly automated lines. They're very cost effective. They're typically smaller than the equivalent drive of the same horsepower in another model line. For example, a 10 horsepower 460 volt GA 500 is significantly smaller than a 10 horsepower 460 volt GA 800. It's the same for the V1000 versus the A1000. So the V1000 was a microdrive, and we manufactured a NEMA 4X version of that drive, which was quite a handy little product. And I'm going to state this right up front. I don't agree with putting drives in NEMA 4X enclosures. And above the microdrive category, I absolutely will try to talk you out of it because it is an economically unfeasible situation. It's also putting a drive that requires a lot of ventilation in a non-ventilated enclosure. However, for smaller horsepowers, and in this case, V1004X was 25 horsepower and below, 25 horsepower in terms of watts is, let's see, 747 watts. The horsepower is 18,675 watts. So if I multiply that number by the efficiency of the drive, which is about the V1000 is 0.03 on the worst day, you got 560 watts of energy. That's 5 100-watt incandescent light bulbs. Ever put your hand on an incandescent light bulb? It's not a pleasant experience. So you still have a lot of energy, but 500 watts it's doable to dissipate that in a NEMA 4X environment. And the way we did it is we made a flat heatsink version of the V1000. In other words, we just put a cold plate on the back of the drive instead of an aluminum finned enclosure. And then we mounted that cold plate to inside another enclosure that had its own heatsink on the back. And thus we were able to waste off 80% of that energy. So here's the 560 total watts loss on a 25 horsepower drive times 0.8 using the flat heatsink design. We're getting 448 watts of that out the back. And therefore, you only have about 120 watts or one light bulb inside the enclosure that you have to dissipate. So now you understand at this level of power, that's workable, that's reliable, and the NEMA 4X V1000 was quite reliable. You have some other problems with that design, like how do you bring the keypad out? Well, we made a NEMA 4X keypad, and it had a nice waterproof front on it. And then everybody started poking it with pens, as they do to make the keypad work, and they would puncture this membrane, and then water would leak in. Because NEMA 4X is rated for 100 pounds per square inch directed washdown pressure. And the X means that it can be somewhat corrosive fluid. So problematic application. Not a lot of volume, but in my opinion, necessary to keep you competitive against everybody else, because there's some other people out there with pretty good NEMA 4X designs. Above a micro drive, I absolutely recommend you do not consider that. Put the drive in a ventilated enclosure and put it outside of the washdown area. Now, the successor to the J1000 V1000 is the GA500. And as I said, we're changing the acronyms on the front end. GA means general application. And we do not have a NEMA 4X version of the GA500 out yet. There are other people who make much better V1000 or much better NEMA 4X implementations than we do. One that comes to mind, surprisingly, is KB Controls, which is now a division of Nidec. They make a really nice NEMA 4X die-cast housing. And what's important about having a NEMA 4X product is that you give the customer the ability to put a disconnect on it at a minimum, if not a circuit breaker. Otherwise, he has to add another NEMA 4X bubble out there next to your NEMA 4X bubble. And some operators on the front that are not keypad oriented, like switches and a pot. That implementation was done very well by KB and several others. Unfortunately, the KB drive isn't very reliable, but their NUMA 4X implementation has been great. And I sent one to the factory saying, hey, we need to do it this way. So the successor is the GA500. The GA500 was expanded to 40 horsepower over 25 horsepower in the 460 volt range. And it is a general application drive. Some of the shortfalls associated with the GA500, in my opinion, the biggest one, we didn't make it closed loop. I think that's a mistake but the product people said, oh, no, we want our people to buy customers to buy GA800 to do closed loop applications. Well, yeah, that's great, but GA800 is a lot more expensive than GA500. And a lot of our competitors have microdrives with closed loop capability. So that's a weakness. And so there, I pointed out two weaknesses, the NEMA 4X and the fact that we don't have a microdrive with closed loop capability. Now we go up to P1000 in the old generation, and that's the volts Hertz industrial fan and pump drive. Its successor, if you guess this, fan and pump, is the FP605. So this is a product that's available up to 1200 amps, which with a very, very efficient motor can be 1000 horsepower. Somebody's not muted, and I'm hearing some background noise, so just check your muting, please. Now, this product line is one of the main workhorses of the Yaskawa offering to the marketplace because it can also do steady state constant torque. It cannot do closed loop. It cannot do flux vector control. Those two applications, first of all, closed loop is for what I call induction servo, so a very specialized line of field of application. And flux vector control is important on a VFD if your load is dynamic, because it allows the drive to react faster. It gives the drive a faster velocity loop, a faster torque loop, and you will keep control of that motor as the load bounces back and forth. If it's a steady state load, such as a conveyor, the P1000 and its successor, the FP605, is just fine. Thank you very much, and it'll work very well. This is a constant torque drive. Just because we say it's a fan and pump drive doesn't mean it can't produce constant torque down to well below 1.5 hertz on a good, efficient, high-quality induction motor. So there's a lot of overlap between the P1000 and the A1000 and the FP605 and the GA800. So bear that in mind. If you get into some price-sensitive situations, you're always perfectly welcome to refer your application to us and say, well, am I okay with the FP605 versus the GA800 in this particular application? And we'll give you a rundown on it. So the next level is the full-featured drives, and GA, general application, similar to the GA500, it's the GA800. And its elder brother, the A1000. By the way, other than the J1000, we're still making all these drives. So availability-wise, a GA800 and an A1000 perform very much the same. And if you can't get a GA800, then by all means, use an A1000. Don't hesitate. A good friend of mine who used to work for Yaskawa, when we introduced the GA, he spoke up in a sales meeting and said, we don't need another drive line. There's not much difference between these drive lines. And he had a point from a feature and operations and capability standpoint. I would have disagreed with my good colleague in that the GA series of products is easier to manufacture, lowers the cost, and has some nice features that are very attractive to some of the younger engineers, such as a Bluetooth keypad, where you can actually operate the drive with your Apple or Samsung Droid smartphone, And those kind of things bring us more into the modern world. However, from a motor control and capability standpoint, he was 100% correct. We didn't advance the art that much. Now, with that said, one thing I really do want to point out is that the GA800 has a faster velocity loop than the A1000. And in 5% of the applications that I deal with where that's actually relevant, it really helps. Much better induction servo control from the GA800 versus the A1000. Now, let's get into some of the other ancillary products that you're not going to run into mostly in your day, but for the sake of completeness, the U1000 is our matrix drive. We have a totally separate class on that. That is a complete departure from all these other drives in terms of hardware design. It is the new generation of drive that in 15 years will be 90% of the market, I'm sure. The D1000 is our active front-end product. This is not a drive. This is not a motor controller. What this is an interface to the power system. Instead of just running the power through some magnetic filters and a diode bridge to make DC, the D1000, by its name, active front end, is a transistorized power supply that is basically a 350 or 700 volt DC power supply to all of our other drives. When you require an active front end pointed at the power line to keep your power factor up and reduce your distortion to less than 5%. This doubles the cost of the drive, and it's where everybody else in the marketplace is in terms of harmonic compliant product. Active front end. Matrix is an active front end drive, but unique. And we're not going to go into that today, but matrix drive does not employ a DC bus, has no capacitors, and is direct AC to AC commutation. Using an AFE is basically like putting a VFD, flipping it around and backing it up and connecting it to your existing VFD such that one VFD points to the motor, the other VFD points to the line, and you have nice waveform shaping going on in both directions. The R1000 is a product unique to Yaskawa. It's a resistorless DB. Those of you that are familiar with dynamic braking applications, when the motor regenerates, it pushes power back to the drive. Current is reversed. The drive accepts that power back onto the DC bus and is fine until the DC bus caps charge up to their maximum limit. And at that point, we either overvoltage trip or we have a method of dumping the power. Unless you're in an active front end or matrix drive, you can't regen back to the line. All these other drives are diode front end drives and therefore need a resistor to dump that energy off. So the simplest dynamic braking circuit is a resistor with one transistor, and that transistor switches on and off and shunts the resistor across the DC bus, absorbing energy off the DC bus and keeping the voltage of the DC bus below the 820 volt DC trip limit for a 460 volt AC drive. And obviously for 230 volt, it's half that. Now, if you don't want a resistor in your environment, it's problematic. They heat up. It's an extra component. The R1000 is that same voltage sensing transistorized switching circuit, but instead of using the resistor as a load, you connect this back to the AC line, and it dumps the power back into the AC line. So it's like poor man's regen. It's a very effective product. We don't sell it enough, in my opinion, and it's extremely reliable. Last is the MV1000, and that's our medium voltage drive. It's there strictly for the sake of completeness. We're not going to talk about that, other than the fact that if you learn how to program a V1000 or a GA500, you know how to program an MV1000. That's how consistent Yaskawa's product line is. Throughout all these products, C101 is accel, C102 is decel. All the E constants contain the motor constants. It's all consistent. Train once, program them all. Okay. Now, we're going to talk a little bit about applications. And when retrofitting a new VFD onto an existing application, I always want you to take the safe approach. And so I'm not going to go over this in too much detail because I want to focus on product today. But this is in the presentation that I will email out to you at the end of this class. And so you can read through it. It's a guide for you when you approach an application where you're retrofitting somebody else's drive. I want you to go through this. I don't want you to just tell me what the voltage and the horsepower is of that other drive. And then sometimes you'll be kind enough to send me a motor nameplate and I have more information. Better yet, I don't want the horsepower rating of the drive. I want the amp rating of the drive. But if somebody has gone out and applied that other drive and it has a problem, and that's why you're in there trying to retrofit it, just telling me what was put in by the other manufacturer isn't going to help me avoid the problem that caused that drive to need to be retrofitted in the first place. So I want a bit more information to keep you safe. Let's analyze the application as if we were the first guy on the scene, not the second guy on the scene, because I don't want to duplicate the first guy's mistake. And this will allow, this little section in this PowerPoint will give you the data necessary to do that. So we're going to move on here to some competitive drive models, and our two biggest competitors in the United States market are ABB and Allen Bradley. Allen Bradley has 26% of the market. ABB and Yaskawa have about 20. Between the three of us, that's 65, 66% of the market. Everybody else is in that other 35%. So some of the other players there may be, you may see them more frequently than others, but Mitsubishi, Fuji, big names in Japan. Yaskawa is not the number one drive in Japan on any given day. It could be Fuji. They're all kind of neck and neck, but those guys don't even exist in the United States to any great extent. I think their market shares are single digits. Why? We can talk about that over a beer. Toshiba, big name in the industry. Certainly the big name in drives when I came on board in the 80s has fallen away in terms of their ability to maintain their market share because of a lot of reasons, and not the least of which is their product hasn't kept up. Somebody that's coming on is Square D from Grippe Schneider, because Grippe Schneider bought Altivar, which was a French company, and frankly, they've done some good work. I have a great deal of respect for the Square D drive, and that's an up-and-comer. For those of you that are worried about the 65 Chinese drive manufacturers that are coming into the United States, or who else is making drives in India or Korea, I wouldn't be so worried about them because they're all in the low single-digit market shares. They have no support. Some of them make good drives, like LS, and certainly Delta from Taiwan is a decent drive. They just don't have the critical mass, the support, the inventory, etc., to be competitive in this marketplace. So they may get a foothold in the market by private labeling for Automation Direct. When you call Automation Direct for support, if you get through their automated support to try to talk to a human, you're not going to get a solution to your problem because there's nobody there that can help you. And with regards to the people that you're looking at on this screen, the pricing's not that far off. You know, I had an OEM who's bought the GA 500 from me for years, called me up and said, hey, I can get an Automation Direct drive, and it's $150 less than your drive. And he buys, 5, 10 horsepower drives. And I basically had to talk him off the edge of the cliff because he's bought over the years probably over 1,000 drives from us, has never had a failure. And I can tell you that the Automation Direct people, when they were private labeling Hitachi, had to recall 5,000 Hitachi drives because they were being misapplied. You can look that up. It has to do with people hooking up their three-phase drive to a single-phase source in their residential air and light industrial environments, and they cause several fires because of that. So there's just not that much cost difference to justify going to a poorly supported and in some cases low quality product. Now, with regards to the big three, these are the product lines. This is how we compete. I will point out that this level of product here from Allen Bradley, the PowerFlex 440 and 500 series, is Delta out of Taiwan. Allen Bradley does not make the majority of their own drives. It's not a bad drive, though. Although Delta did have a control transformer problem back in before COVID that caused failure of a couple thousand drives in the United States. We won some accounts, and user accounts, because the drives kept popping off because the control transformers were faulty. Nevertheless, the 700 series drive from Allen Bradley, I have a great deal of respect for. It's a good product, and it's designed by Allen Bradley and manufactured in the United States. ABB, our most serious competitor worldwide. And while Allen Bradley doesn't get into the top 5 in worldwide drives, ABB and Yaskawa are definitely punching it out for number 1, number 2 in the worldwide marketplace. And ABB's products are good products. The only thing I can say about the ABB product that is a worthy criticism is in heavy-duty, high-cycling applications, such as the oil beam pump, the pump jack, where you're lifting and lowering the rod string every 6 seconds, or extruders and other heavy-duty, high-cycling, dynamic applications. And this is getting way in the weeds, but the temperature variation on the junction of the transistor for Yaskawa versus ABB on heavy, high-cycling applications, we've tested them side by side. And Yaskawa's temperature variation, for example, in the pump jack application, we're varying 5 to 7 centigrade on the junction, and ABB's variation is twice that. So it caused them some problems, because if you take any material and you raise the temperature, lower the temperature on a high cycling basis, think about trying to break a piece of wire. You bending it back and forth, back and forth. Eventually, you're going to mechanically work that wire's characteristics, and it will break at the point that you're constantly bending it back and forth. Similar principle from a thermal deviation standpoint, but that's really the only criticism that I can think of. So Yaskawa, I always recommend going to Yaskawa on heavy-duty applications, but the ABB product is a superior product to pretty much everything else I've seen on the marketplace except Yaskawa. So that's how our products line up. Now, if you're interested in Toshiba in this presentation, there's a comparison of Toshiba's products. Now, one final note: if you're doing the MRO game and you're out end users, or you are an end user and you want to decide as to whether you repair or retrofit, I would say that I wouldn't even think about it. 75 horse and below, replace, especially if the drive's 20 years old, because the drive's life expectancy is about 20 years. So your components are all at the age of geriatric status. And if one fails, you know that the rest of them are just about ready to fail because they've all reached their end of life points. So in that case, repairing a drive, unless it's an absolute exigent situation where you need the line running in an hour and you happen to have some transistors, that is not a path that I would take. I would always replace new. You're spending your money much better doing that. 100 horsepower and above, depending on the life of the drive, these are much more feasible for repair, especially in situ repair on the big stuff. And there are competent outfits in town that can do that. Yaskawa has their own division of field service. little bit expensive, but certainly competent. And that's kind of the way I would guide customers in terms of deciding whether they want to retrofit and repair an old drive. Okay. Now, back to the website. I'll talk about some model lines here and why I think the new model lines are. This is always the case. Where I got to sneak in here there. Okay, got it. All right. So, by the way, our HVAC drives to complete the discussion is basically the Z1000 and the HV600, which are very similar to the P1000 and the FP605, but they have very specific features for HVAC, which is heating, ventilation, and air conditioning, also called commercial marketplace, also called human comfort. When the drive is controlling equipment that is for human comfort, whether it's a compressor, centrifugal compressor for the chiller, whether it's chilled water pumps, whether it's fans on air ducts, it's HVAC, and it's a marketplace unto itself. Either you're in this market or you're not. And it's very spec driven. It's very much construction oriented. And we make a special product line specifically for that. It's also extremely cost sensitive. So these products are, for most of the manufacturers in the world, stripped down versions of their industrial products. So with that said, the HV600 is our new drive for that market, HV for heating and ventilation, HVAC, and it replaces the Z1000. Now, in this marketplace, and I'm going to illustrate this to you now because it also applies to our FP605 that you will see in a moment, we have a lot of additional configured product options for the basic drive. Up here is the basic drive. Drive in a box, take it out, and it's basically, you need to treat it like your stereo system, which means you need to put it in an electrical enclosure, ventilate it, make sure the temperature is controlled, make sure that water and dust don't access the drive compartment. In the HVAC industry, because it's a specification-driven industry, they still spec a lot of contactor bypass, which was something that came up in the 80s when drives weren't very reliable. And customers said, well, if the drive blows up, what do I do? And we came up with a product called a contactor bypass, where you isolated the drive with a couple of contactors on the north and south end of the drive, and then you had a bypass motor starter that was parallel to that circuit so that you could take the drive out and start the motor across the line. And it was great, but you didn't get variable speed. Today, using bypass, in my humble opinion, is a ridiculous expenditure of money. It's cost another 25, 30%, and it's completely useless because drives just don't fail at anywhere near the rate that they used to fail. In the 1980s, when bypass was conceived and productized. However, being a specification-driven industry, specs are somewhat not up to date in many cases in many projects, and we have to bid them, and they require bypass. So we have all sorts of bypass options for the drive. And in this case, I'm sorry, this is really small. I should have put a bigger, can I zoom this? No, apparently I can't. Let's go to something that I can show you. What I'm doing here is I'm giving you a quick tour of the website without actually telling you that I'm doing that. But let's look at a download. Oh, there's the brochure for the HV600. Now, basic drives with bypass. So this is an over-under configuration. Here's another basic drive with bypass. This happens to be the electronic version of it. So the keypad is actually on the front end of the bypass container. Note, these are tall, skinny, because in buildings, you got a lot of height, but you don't have a lot of width. So to make more use of the situation of the location, you want a tall, skinny drive. Here, note, the drive is exposed. It's going to be put in a clean environment in a building, in the HVAC control room. So no dust and no water. And therefore, we don't have to enclose it. However, we have enclosed configured products, such as those seen here, which is what you would do more in an industrial environment. So the HV600 product line, drives only, drives with bypass, but NEMA 1, in other words, for clean environments only, and then the basic drives in their configured packages. And we'll go over more of the configured package options when we talk about the industrial drives. So, okay, now, so we're going to go and talk a little bit about microdrives now. And again, I'm using the website and navigating the website like you can navigate it. Here we still have the old V1000. Let's take a look at the V1004X. This is, sorry that I can't. So there is the NEMA 4X in a washdown enclosure. It has the keypad on here. Note there's no disconnect, no circuit breaker option, not an advantage. And all your switches are going to be off the keypad, which is fine because you get full functionality off the keypad. But like I said before, people poke at this with a screwdriver or whatever, and then they permeate the membrane, and now it's not NEMA 4X anymore. So back to, we'll skip over the GA500. We'll go through, or the V1000. We'll go directly to the GA500. Now, 1 to 40 horsepower, like I said, in the 460 volt range, and the best document for GA500 is the BL for bulletin. When you can get an SL on our product lines, that's called a selection guide. That's by far superior to the BL. We have one for the GA800. We don't have one for the GA500. So this is the GA500. I pointed out that it doesn't have closed loop. That, in my opinion, is a disadvantage. The keypad on this sucks. It's an LED keypad. I have no use for LED keypads anymore. But the fact is that the price class and the size that this product is in, that's the only option. However, most of the time, these drives are going to be mounted in an enclosure. And by the way, you can butt them right up next to each other. They'll still cool with zero space side by side. So while we're on the subject of the keypad, use the optional keypad. This is the GA800 keypad on a GA500 drive. And then you've got a full function keypad. People hate programming it this way. And my answer to them is hook your laptop up to the micro USB port and program it with Drive Wizard, or use the GA800 keypad, which is a $160 list option. And if you're mounting 20 of these in a cabinet, you only need one keypad to program it. But if you want to buy 20 keypads, okay, that makes it into a GA500 with a GA800 keypad capability. Again, typically in these applications, you're going to be mounting this on the door anyway. So those are the two big disadvantages. One of the reasons that I really liked the GA over the V1000, remember my colleague saying, well, we don't need any new drives. You couldn't program the V1000 unless you powered it up from the power terminals. You can program the GA500 by plugging in your laptop or via USB your smartphone. And by the way, that only applies to Droid products. Apple doesn't comply to the USB conventions that are required to interface via a hardware link and therefore power up the drive. But if you interface via a USB hardware cable, the drive powers up on the USB power bus, and you can program the drive in the box, which is what this little picture is here. And that's a really cool feature, especially if you're in the distribution business and you want to put a custom program in to provide some extra service level for your customer, like his parameters, so that the drive arrives with his parameters and he just bolts it in. But then you'd have to power it up with the older style drives. This one, nope, just open the box, plug in a USB cable, and use Drive Wizard in a laptop or a tablet or a smartphone, and you're good to go. So I think that's a really important feature. By the way, this optional LCD keypad, you can also use the Bluetooth version of it. There's two versions of that LCD keypad. The one you have to push buttons on and the one that is Bluetooth capable. I like the network integration that we have implemented on the GA500. GA500 is an OEM drive. And by the way, the reason we're not bringing the J1000 forward into its own GA product line is because the GA500 is just as cost-effective to manufacture as the old dumb shaft turner J1000. So that's why the J1000 was eliminated. So the GA500 is the new J1000 and the new D1000. And here's one of the things I really like about it. In networking, these are the inexpensive drives. You know, they're a few $100s to around $1,000 for these drives. These network cards from Yaskawa, all of our COM cards for Ethernet IP, Profinet, Profibus, etc. Our COM cards are ridiculously expensive. And so are everybody else's COM cards in the VFD business. The reality of it is these COM cards should cost about $50, and they don't. They cost about $200, $250. However, with the GA500 and its RS-485 internal networking, you can cut the cost down to $50, where it should be if you're using multiple drives, because the PLC communicates to one COM card on this drive called the node master, and all the other drives are accessed by the PLC through the same COM card through this RS-485 network that's just nothing more than wires connecting the other four drives to the main drive. Now, you have a single point failure. Okay, I'll acknowledge that. But the reality of it is it saves a lot of money. And these days, all these components, including the COM card, are pretty reliable. They're all north of 500,000 hours MTBF. So that's another feature I like about the GA500. Obviously, that applies to the GA800 also. Now, as far as controlling motors, we have the ability to control permanent magnet and induction motors with the GA500. And some nice installation solutions like thin rail mount, heatsink out the back. That's very important. This NEMA 1 kit is something unique to the United States. If you're going to mount this on the wall and you want to comply to NEMA 1 rating, you got to put this metal thing down on the bottom of with it, and it's got conduit holes. It's where you can land your conduit. This is unique to the United States. We don't sell it anywhere else. But in the United States, it's required if you're not putting the drive in its own enclosure. Okay, now let's move on to the 800 because we're running out of time here. Somehow these drop-down menus drive me nuts. Yeah. So again, navigating around on the website, products, general purpose drives. Here we have the GA800, and we're going to talk a lot about the GA800 configured drive, because I want you to understand we have a whole division that does configured products, and you can put drive in a box much more cost effectively based on Yaskawa's configured products than you can using a third-party panel shop. Now, hold on 1 second here. I'm looking. This is a product where we have a selection guide. And unfortunately, I don't see it here. It's under specification guides. Bear with me 1 second. Oh, let's see what this is. Oh, this might be just a text. Yeah, that's just a Word document. I don't want that. Let me pull something up from I can't find it on the website and I don't have enough time to screw around. So let me just pull it off of my hard drive here. Selection guides from Yaskawa, in my opinion, are the best piece of literature we've put out there. Oh, we do have a selection guide for the GA500. I didn't realize that. All right, I'm just going to show this to you quickly. This is the GA500 selection guide. And we can shut off all this stuff. And what it is a much fuller version of the much more information, all the dimensions, etc., and all the options associated with the GA500. By the way, there's the GA500 finless drive that will be the core of the GA500 NEMA 4X when we introduce it. Very similar to the, notice, no heatsink fins on the back of it. So that's the selection guide. Every different aspect of what's available on it, even including a definition, because I can never remember whether it's mini or micro. And I said micro earlier to plug into the GA500 programming port. I was wrong. It's mini. So this is I would definitely use this as your main document in terms of specifying the product, okay? But we want to talk about GA800 now, so let's go back to GA800. Okay. Now, this is the GA800. It comes standard with the LCD full-featured keypad, HMI, call it what you will. And there are some very nice modern features to this, such as, remember when you want to get the nameplate data off the drive, because I'm always asking you for the nameplate data, and you go to the drive, and Yaskawa would not put the nameplate on the front cover because the front cover is removable. So they put it on the side. And you can't access it unless you have a lit mirror or some sort of a snaky scope camera because the drive's inside an enclosure. Well, smart. We put a code on the front. You scan it, you get all the data. That's a nice feature. I've actually taken my little extendable mirror out of my briefcase now because I don't need it anymore. Same thing with the NEMA 1 kits on the drive. Same thing with no space required to mount them side by side because they all ventilate top to bottom, or bottom to top, I should say. And the same thing with the networking aspect of this. A very capable networkable drive with all of the industrial protocols required. By the way, all of our industrial protocols except Modbus RTU, which is an RS-485 protocol, are option cards. Why? So that we can make the drive the same way all the time. So the native serial COM is Modbus RTU. If you want Ethernet, you got to put a card on our drive. And as I said, they're in the $200, $300 range. But that allows us to make one drive consistently, and we make 5,500 drives a day. We don't want to make a whole bunch of different flavors because that affects quality, cost, consistency. And that's why most of the big boys will have optioned COM cards. Okay, now the digital tools associated with the GA800, again, scan all the data from the front. Drive Wizard, that is a program that we will teach a class on. You need to be familiar with it if you want to be competent in Yaskawa drives as a sales applications person. And right off of your Droid or Apple via the Bluetooth keypad, which is an option. Bluetooth keypad is another $250 option. But it allows you to wirelessly communicate to the drive, program it, and actually run it in a limited way. Or connecting via the drive COM port here, and again, USB mini, and allowing you to direct hook up from a laptop or a tablet and use Drive Wizard to program and configure the drive. Also, we will have a class on Drive Wizard. Drive Wizard has an onboard oscilloscope function that allows you to do analysis. You can run your drive and create scope traces that you can then save and send to us, and we can see what the drive is doing. And you can, it's a 5-channel or 6-channel scope. You can basically chart 6 different parameters from the drive's data read-only registers, like current, output voltage, heatsink temperature, et cetera, et cetera. So a very, very capable product. Now, this was not, I wanted to show you the configured products. Hang on. Here. We don't have a good configured product brochure, I guess. Apologize for that. I will not be able to show you the configured product, but let me just explain it. Anything you can do in a panel shop, you can theoretically do at Yaskawa with the following limitation. And I'm going over here a few minutes, bear with me. I'll wrap this up in 5 minutes, and then we'll, in a subsequent session, we'll do the FP605. But the configured product from Yaskawa is the division currently in Oak Creek, soon to move to the other side of Milwaukee, where we are making a whole new campus for Yaskawa, where all of our facilities will eventually be consolidated. So it's kind of cool. But the Oak Creek facility is a gigantic, and I'm not going to call it a panel shop. I'm going to call it an assembly center. And the reason for that is this. Our people in that shop are United Auto Workers union members. We are a union shop. This is a UL 508 rated facility. But these are not panel people. These are assemblers. And they don't have a job requirement of understanding electricity to do the job. It's a very important point because if we make it, you can buy it. But if we haven't made it before, forget it. And that is because we're so highly documented that you have no ability to do specials through the Yaskawa panel shop assembly center. Why? Because everything is video documented for the assembly people to put together. Wire harnesses, pre-drilled, pre-tapped holes on the sheet metal. We do not use Hoffman enclosures at the configured package division. We only use pre-designed sheet metal. I'm bringing up the quote wizard here to show you the configuration tool for the by the way, this is the quote wizard. And it always tells you to update when you need to update. I'm going to ignore that now because I don't have time for it. But this is the one tool I would use if you're doing any pricing for your Scout. I don't use catalogs and price books anymore because they're not up to date. Now, I'm going to show you very quickly to illustrate the configured product capability of our products, G800 and configured package. So we're going to select a NEMA 3R, which is an outdoor duty enclosure. NEMA 12 is industrial indoors, and NEMA 1, as I told you, is clean in a clean room, no dust, no water. And we're going to choose, let's choose 100 horsepower or 60 volt drive, which would be, there we go. So configure the product. There's your list price for the drive only. There are the dimensions, there's the weight, and there's your rudimentary specifications. I'm going to go and configure the product. If you can configure it in this, you can buy it. If you want an extra button and we don't have it in here, you can't buy it. And that's the limitation with a highly automated configured package product offering. But we offer a lot of stuff. Let's put in a 65,000 amp breaker or a standard 18,000 amp breaker or a big 100,000 amp breaker, or maybe just a disconnect switch alone. The minute you click it, you get a price and we start to configure the product number. Here's the base product number, P for all the power options, T for the control options, and S for special options. And I note that power option C, which is the circuit breaker, is now added into the configured product part number. And the pricing is noted. Do I want input fuses as well? Yeah, why not? Because sometimes you need that short circuit interrupt capability on big drives, and the circuit breaker isn't going to give it to you, so you add fuses in to comply. Line impedance, you want an input line reactor? There you go. And you can see that we go down this configuration menu and we select everything that we need to make the configured package. It necessarily limits us to only what is available from the Yaskawa automated configured product line. Ambient rating, 50C. I want a 50C instead of 40C. Why? Because I live in the Southwest and it gets to 120 degrees. Basically, what this gives you is a whole bunch of extra fans in the NEMA 3R enclosure. So added airflow, basically a hurricane. And it allows you to put that drive in a 50 degrees C, which is 122 degree Fahrenheit environment. And I don't know of any plants down in the LA basin that don't get to 120 degrees at some point in August when it's 110 outside. So here we have noted all of the power options, right? Surge protection. You want lightning protection? Put that in. Now, EMI RFI filters. There you go. Here are the control options. Option 1, here's all of your communication bus options. Are you interfacing to an Allen Bradley PLC? Yes. We're going to add an Ethernet card, option D, to the T-class option designations. These allow you to have a second card, which would be like more digital inputs, more analog inputs. Typically, you would not put two COM cards on the same drive. I've never seen that done. And then option 3, again, there are 3 ports on the drive, so it gives you the option to configure all 3 ports. There is your PGX3 feedback card to close the loop on the motor encoder, if you so have one. Input terminals, you want to put 120 volts on the drive, we have an interface for that as opposed to the dry contact interface that's standard. Speed pod, keypads, here's where you option out your keypad, and there's the Bluetooth keypad. Okay, so now let's add that to the quote. Do I want additional information? I don't have time to do that right now. Here's where you determine your multiplier and your net price. So if the list price, remember it was $26,000 list price for the drive. Oh, that wasn't right. Hold on a second. It's $26,000 list price for the total package. Okay, let's add that to the quote. 26,000. What is just the drive? So we can know how much we charge to put it in the enclosure with all those fancy features. Let's go to a standard drive, and we were at 124 amps, 460 volts. So 100 horsepower. No duty. There we go. $12,000. So the list price for the drive is $12,000. In a NEMA 3R enclosure with a high interrupt circuit breaker and fusing and all the other options that I specified, it basically doubles the cost of the drive. So from 12 to 26 is $14,000 list, netting out to the customer that's going to be probably around, I don't know, $9,000-10,000. Can you do that in a normal UL 508 shop for a 100 horsepower drive? I think not. This, by the way, is a tested product, and we thermal test all these products. They're not just calculations out of the back of the Hoffman enclosure book. These are thermally tested, and this product can run to 122 degrees Fahrenheit. So an illustration using the pricing tool of the configured product and how economic it is versus the standalone drive versus sending your drive to a UL 508 shop and having it put in there. Now, some of you have UL 508 shops. I'm not trying to talk you business out of you. Build it in your shop if you like, but this is an option for you if we can do it less expensively. Okay, I've run over time. Thank you very much for giving me the extra time today. I hope this was useful. We did take a look at the website, the Solution Center, and the Quote Wizard tool to configure configured products. Next week, I don't know what's on the schedule. I didn't look it up, but I'll send out an announcement. Once again, we are Western Automation on YouTube for the recorded classes. There are some on there now. There will be a lot more on there as it's one of my duties to start editing and putting classes up there forthwith. So you'll be able to review any classes you like on the YouTube channel. With that said, it's 8:13, time to go to work. Thank you very much and have a great week.
Thanks, Pierce.
All right, see you next week.
Thank you, Pierce.